So I wanted to say a couple more things about this function that we developed for r of delta t, and particularly what does the graph of that function look like? What can we learn from looking at the graph? So here's the function that we came up with, negative 1.17 over 2 delta t times 3750 plus 2 delta t squared over delta t. And we find that it reduces, we can reduce out the delta t's as long as the delta t is not equal to 0. Problem being delta t equals 0 is exactly what we're interested in if we want the instantaneous velocity at t equals 25. All right, so I just transferred this stuff over here so we have some room to write. So yeah, what does the graph of this look like, and what would that graph be telling you? So here is my TI with the various functions that we've been talking about. So this is the function that gives the position, this is the function that it gives the r of delta t, and this is the reduced function that gives the position of r delta t. Now I want to look at graphs, but I don't want to look at all of these graphs. I really only want to look at the middle one, and but I don't want to delete these graphs, the other two graphs. I want to leave them on there. So this is another calculator technique, because I might want to use these other functions to calculate with again. So I'm going to leave them in there. So what you can do is you can go over to the equal sign, so arrow over to the equal sign. So now the equal sign is flashing. And I press enter, and now it's flashing, but it's unhighlighted, right? So basically by unhighlighting the equal sign, what I'm doing is switching that graph off. So I want y1 to be switched off, I want y2 to be switched on, I want y3 to be switched off, so I arrow over to the equal sign, press it, it's now off. That's a toggle, so I could go over here and press it again, and now it's back on. All right, but I want it off. So there you go. Now, the next thing we have to think about if we're going to graph this is the window, especially some of these graphs will graph sort of slowly. So we want to think about the window beforehand so you don't have to like keep trying to zoom around for it. So if we think about our delta t, we use numbers that were very close to 0, we use all positive numbers, and we went up to a maximum of 10. So for the x values, I want to go up to 10, but I also want to look at the negative side of the graph. We didn't use that, but I want to think about what it means. All right, and then for our y, what's our domain for y going to be? Well, we know that, like, we need to think about what this graph is. So I know that the reduced graph is the same as the original graph everywhere except at one point. So it's going to be a good guide for what I should set my window. Now, what does that graph look like? It's quadratic. So you tell me what it should look like. Take a little pause. Think about this. Think about how I could do distribute the negative 1.17 over 2 and get this function, and you tell me what should that graph look like and what should I set the y values to be. So take a break and figure that out. Okay, so what you should realize about this function is that this is a parabola facing downward. So this is a quadratic because of the delta t squared. The leading term is negative, so that means it's a parabola facing down. And what this is giving us right here is the vertex. So we know that this is a parabola facing down with a vertex at 0, negative 2,193.75. So what does that mean about my window? Well, I want the top of the y window to come up higher than this. So let's say we come up to negative 2,000. All right, and then at the low end, we don't really have a clear idea like how far down this thing's going to go. So I just took a guess and said, let's put it at negative 2,500, and maybe that'll give us a view of what the graph looks like. And if it's not, we'll have to change it. But the idea is analyze the graph before you graph it. Come up with a good idea for the window so that you won't waste a lot of time changing the window around. All right, so let's go ahead and set that window. So here's negative 10 to 10. I decided to keep that. For your y's, we're going to go, for our y min is going to be negative 2,500, and our y max is going to be negative 2,000. Now here's an important thing is I have a range on my y's that covers 500. So if I leave that y scale at 1, that vertical y-axis is just going to be like a thick black line because it puts in a tick mark. It's going to put in 500 tick marks. All right, so what we want to do is change that to something like 100. So anytime you have a large span between either your x min and your x max or your y min or y max, you want to set the corresponding scale to be a number that is correspondingly large. Now we're going to look at what that graph looks like. Yeah, look at that. All right, very nice. Now, that was a graph of this function. So we're going to talk about what this graph means. But first, before we go to the next video, looking at this graph and looking at this equation that is the equation that we graphed, there is an important feature on this graph that your calculator is not showing you. Arguably the most important feature of this graph. By the way, we see that it's, as we predicted, a downward facing parabola with a vertex at, slightly lower than -2000. We can see that. All right. But what feature is missing? The most important feature of this graph. So I'm going to let you think about that while we go to the next video and write down in your notebook, what do you think? What is the feature that is missing from this graph?